Hi, I'm Nick Salkowski. Hi, everybody. I am going to be talking about S3 methods a little bit, and am I too loud? Perfect. Okay. And also just how you can use S3 methods to just do some quick plotting stuff. Just the sort of stuff that I find annoying and what I think is a solution to it, at least a solution for me. So I am not an expert on different kinds of R classes, or really S3 for that matter. But the nice thing about S3 is that you can use it without really knowing what you're doing very well. It's pretty simple. It lets you be sloppy. Sloppiness is allowed in S3, so you can learn it, or at least you can take advantage of it, even if you don't consider yourself to be an expert. And I'm certainly not an expert. It's also kind of nice to know a little bit about S3 because a lot of the R functions that you know and love are built around using S3 methods. And so this kind of gives you a little bit of insight for what is actually going on behind the scenes when you call some of the common functions that you call. So here's sort of an example of S3 in action, right? So I'm going to build myself a little factor vector with some letters in it, and I'll construct myself a numeric vector with just some random normal data in it, and I'll call the summary function. When I call the summary function on my factor vector, I get the counts of each level of the factor. When I call the summary function on my numeric vector, I get the mean in a bunch of quantiles. So obviously something is going on because the function acts differently depending upon whether I give it a factor or I give it a numeric vector. And this is S3 at work. So if you actually look and see, well, what does the summary function actually say? And it is remarkably short. It just says that summary is a function of an object and some other stuff. And it just says use method summary. And this is kind of inscrutable unless you know what's going on. So what happens is that summary has a bunch of methods associated with it. And all of these methods, which actually fill up my screen and more, are functions that will be called by R depending upon the class of the object that you feed to summary. So if I give the summary function a factor vector, it's going to run summary.factor. And if I give it a date vector, it'll run summary.date. And if there is no special, if it can't match the class of the object to any of these functions, it'll run summary.default, which I believe is what happens when I feed it a numeric vector, because I don't see a summary.numeric on this list. So perhaps that's the default method. So if you look at the individual functions here, summary.factor, you can't see the whole thing here, but it's a pretty conventional looking R function, right? There's nothing extra special or weird about this. This is the kind of R function that you write all the time. It just happens to have a special name. It's summary.factor, and summary just happens to be a special kind of function that calls methods. So a lot of things that you use all the time use these S3 methods, like plot. You might have noticed that the plot function will give you a different kind of plot depending upon what kind of data you feed it. This is how that works. There are other things like the coef function for extracting coefficients will do different things depending on the kind of model you give it. Or the hist function, which is for making histograms, there's a default, but there's also one for dates and other dates. Go figure. Anyway. So this is the way that all of this stuff works. So like I said, S3 is kind of sloppy. And so one of the things you can do in S3 is basically invent your own classes. And you can just, and R doesn't really check on anything. You can say the class of this object is fish. And R says, great, that's a fish class object. You don't have to do any kind of crazy setup. You can just say, I have this thing, x_fish, and its class is fish. And I'm giving it two classes here, fish and integer, because I don't necessarily want to write all of the functions associated with fish, right? I mean, basically what R is going to do, if it sees a fish class object, it's going to go, well, do I have a fish method for this object? Oh, if not, well, do I have an integer method for this object? Oh, great, I'll use the integer method. So it's kind of like a backup, right? So it's kind of going to go down the list, go down the classes, and it'll use the first one that it knows what to do with, right? So I don't want to go and figure out, okay, I have my new fish class object. So do I want to say, oh, I need to create print.fish and plot.fish and summary.fish, although that's exactly what I did here. You don't necessarily want to do all of those things necessarily. And letting R know that, my fish class object is also an integer, helps it out a little bit. So here I wrote a summary.fish function where I just say, well, just do a table, right? Which is not what would normally happen if I gave it an integer, right? If I give it an integer, it's probably going to give me the mean and a bunch of quantiles. But because it's a fish class object, when I run summary of x underscore fish, it gives me the counts of the various values. Hey?
Does S3 have inheritance?
Inheritance? Yeah, there's inheritance, I believe. I think. I'm not, but don't take my word for it. Check on it yourself. Like I said, I'm not really an expert on this. But the beautiful thing is that with S3 is you don't really have to be an expert to make stuff work. I mean, that works. I mean, it's kind of a goofy example, but it works. So this is my motivation for what's going on, for what I'm doing. And it'll come back to S3 in a moment, so just bear with me. Sometimes it's nice to have just a little summary plot of your data. It's nice. You can look at your data. It's a really great thing. It's good for exploring your data. It's good for debugging. And there are lots of great functions for exploring your data. And but most of them work on one kind of data to produce one specific kind of plot with one specific type of data. And I don't really like writing code that says, if is vector x, then do this kind of plot. Or else, if it's numeric, do this kind of plot. Else, if it's a date, do this kind of plot. I want to just be able to go, oh, just plot my data, please. Whatever it is, just plot it. And figure it out. And you can kind of see that S3 is a useful way to achieve this. Because if I write a function and the first thing it does is check, well, what kind of class of object was I just given? Oh, yeah, I was just given an integer vector. Well, then I will run the function for an integer vector. And so that will save me from writing a bunch of if statements in order to decide what to do for these various things, because stuff doesn't always work. So here are my two examples, and I'll come back to these a little bit later on, of some ugly data, of some slightly ugly data. Okay, x1 is a numeric vector of doubles, but in addition to 70 doubles, it's also got some minus infinity and plus infinity values, and some things that are not a number and things that are just plain missing. Okay, and x2 is a factor vector with a, b, c, d, e, but it's also got a bunch of missing values as well. And this is sort of one of the things that I find annoying. So if I'm kind of trying to do my data exploration or trying to debug my code or whatever it is, and I want to know what does x1 look like? Well, if I call the hist function, I get a histogram of x1, and there is absolutely no indication whatsoever that there are infinite values in this data, that some of the data is missing. That doesn't show up here at all, which is kind of annoying. Don't even try to give hist something that isn't a date or numeric. It will just generate all sorts of problems. It won't even, it doesn't work. If I have a factor vector, I can do a frequency plot fairly easily with bar plot table x2, and again, it ignores the fact that there's missing data, which is the way it's designed, because for factors, you have to explicitly tell R that missing NA is a level of your factor, and if not, it doesn't consider it a level of your factor. So it doesn't show up in your table. And then if you try to do this with a numeric, you get this, which is correct, but not as informative as it might be, right? Now, ggplot2, you've got your qplot, which is a useful function. I am not a ggplot2 expert. Please don't ask me questions about ggplot2. I know almost nothing. But if you give it a numeric vector, it'll do a nice little histogram. Again, completely ignoring the fact that there's missing data there. And if you do give it a factor vector, it will do a frequency plot or a count plot, and it actually brings in the NAs, which is nice. Although it doesn't really make the NA stand out. If I was just kind of like glancing at this, I wouldn't necessarily notice, hey, that bar on the right says that stuff is missing. I have to look a little carefully on that. So from my point of view, there are some drawbacks to a lot of these things. Hist only really handles numbers and dates. Using bar plot and table doesn't handle the double precision numbers very well. None of these really support lists or data frames very well. If you say, give me a histogram of this data frame, it's not going to happen. And qplot, is the same way. I mean, you could use lapply, if you were to take your data frame and use lapply and take your data frame and apply the qplot function to every element in the data frame to produce a bunch of plots. But that will work for a data frame. But if you say lapply for something that's not a data frame, that's just a vector, and then with your qplot, then it's going to plot every single element of your vector separately, which is not what you want either. And the non-finite and missing values are often dropped, which can be a good thing or a bad thing. I would want to know if I have weird values in my data. I want to know how much of my data is missing. And I want that to be obvious when I'm doing debugging and data exploration. So I wrote a package. Okay, I am not great at writing packages yet. It's a little rough around the edges. It is available on GitHub, and it's called Pyther. Okay, now the thing about this is you will probably not remember my name. Okay, but as of a few minutes ago, if you search GitHub for Pyther, the only stuff that shows up is the Pyther package and this presentation I'm giving you right now. Okay, so if you can remember those 5 letters, you can find this, if you want. It's really up to you. So what is this crazy name all about? Well, I wanted something that was short. I don't want to spend all day typing. And you would not believe how many things in R are named some sort of variation on plot. Okay. Xplot, qplot, ggplot. I wanted something different, but it's also short. And I ran into Pyth. Now, one definition of Pyth, it's not the first definition, it's the second definition, but it is a definition of Pyth, is the essence of something, right? And also, when used as a verb, it means to extract the Pyth. So what I want to do here is metaphorically extract the essence of my data, the sweet, sweet essence of my data. Okay? This is what it's about, and it's only 4 letters long, so you don't spend all day typing. Okay? Now, you can, of course, install Pyther by using DevTools and install GitHub, which I'm going to assume that you're either all familiar with or you can figure it out. It's really easy. And so I'm just going to go through the way that this package that I wrote works. And the most basic command in the Pyther package is pith. And the nice thing about pith is it just handles a wide variety of data types and structures. And it's using S3, so it's going to see what sort of object was I given, and it's going to produce a plot that's hopefully semi-appropriate for the data I was given. Now, so you can see what happens. If I haven't given an integer, at least a short-ranged integer, it'll just give me a frequency plot of all of the values of an integer. Now, if I give it an integer that has a long range, I'm going to produce a histogram. Now, the idea behind this is that I don't really want to look at more than 25 individual bars. If I have a spread of integers that's 500 wide, I'll just do a histogram. Is this perfect? No. But, it is what it is. I got to make a decision. If you do give it a double precision number, you get a histogram. If you give it a character vector, you get a frequency plot. Same thing if you give it a factor. If you give it a logical, you get trues and falses. If you give it a date, you get a histogram of the dates. If you give it a matrix or an array, it's going to collapse it down to a vector. Why? Because I have no idea which are the meaningful derived dimensions in your crazy matrix or array. Okay, you may know that, oh, the columns are where it's really interesting, or the rows are where it's interesting, but I don't. And there's no way for me to automatically detect which way your matrix is set up. So I don't do anything with it. I collapse it to a vector and say, here's the contents of your matrix. Here's the contents of your array. And of course, you can sort it out some other way if you want to. You can always use apply, right? And if you know which direction you want to do stuff with, use the apply function. That's what it's for. If you give it a list or a data frame, it's going to go element by element, column by column, and plot every single one of those elements of your list or elements of your data frame. So in his case, I give it the cars, and I get speed, and I get distance, or speed and distance. And remember those two kind of ugly vectors I had from before? The one that was x2 is the factor vector with a bunch of missing things. This is what I get if I feed it into Pyth. I get a frequency plot of the non-missing values, and I get a bar for the missing. And the bar is separated out on the right, and it's a different color. So that if I'm just glancing at this, I go, hey, there's missing data there, which is often a useful thing to know. Same thing happens with my numeric vector with oddball values. I get a histogram of the finite values and a bar for plus or minus infinity and a bar for missing or not a number. Obviously, we could have 4 bars, one for minus infinity, one for plus infinity, one for not a number, and one for NA. But for the most part, that level of detail I thought was best for like a second stage of checking on stuff. You can feed some arguments to Pyth if you really want to, but for the most part, I'm trying to build something that you don't really have to customize. The idea is to do something really quick and simple and to provide something useful that is not necessarily something you want to spend all day customizing, but it does take arguments. So you can, change the title and give it some, change how the histogram breaks are made, or give it some other plot parameters. You can change the colors if you want. If you don't like blue and red, you can change them. You can do this, but the purpose of this is not to make beautiful plots. It's to just generate something and not pay too much attention to it. So, in addition to Pyth, there's also Pythy. And Pythy is there because it's kind of like Pyth, so it's Pyth-E. And basically, what Pythy does is it takes your object, calls Pyth, and then instead of returning a Pyth class object, which is what Pyth normally does, because I modeled Pyth off of hist. So if you know how the hist function works in R, and you call hist, it will generate a plot if plot is equal to true. You can set plot equal false if you want. It will generate a histogram, and then it will return invisibly a histogram class object, which is a list with a bunch of things about where the breakpoints are and what are the counts for each bin and things like that you can use to make a histogram later on, or just to kind of break down what are the underlying data that goes into the histogram. So Pyth works the same way. It'll create a plot if plot equals true, which is the default, and then it'll return a Pyth class object, which is full of all sorts of stuff about your data that's used to make the plot. But that's not necessarily what you want to do all the time, so there's Pythy. So what Pythy does is it runs Pyth, but instead of returning the Pyth class object, it just returns the original object. So it does nothing, which is kind of nice because you can use that with Magritte or dplyr or things like that in order to see what's going on here. So here, this code generates 100 random uniform values, and then I just wrap that inside Pythy and assign it to xunif, and xunif is those random values. That essentially Pythy says, make a plot of this and then return that thing, unchanged. And which is kind of nice if you want to use it with Magritte. So I can, in this case, generate some data and then send it to Pythy and assign it the value of some value. And so I can make a plot on the fly without messing around with too much stuff. You can also do the same thing with dplyr. In this case, I have the iris data set. I'll select sepal length send it to Pithy, and then I'll use transmute to create a sepal length squared variable, and I'll send that on to Pith. And so I can produce the histogram of sepal length and the histogram of sepal length squared, because Pithy doesn't do anything in my chain. If I were to take Pithy out of this chain, it's the same. I don't change my data when I use Pithy. And I also created some special dplyr plus Pithy functions because I kind of thought that if you wanted to make a little detour to do a little plot in your data, you might want to do something like filter it or select a single data element or things like that before you do your plot. That way you don't have to plot your entire data set. Because remember, that's what happens when you feed a data frame into Pith, is it creates a plot for every column of your data frame. But just like Pithy, they return the original object before any filtering or selecting or mutating happens. So here, I can take the iris data set, I'll run select Pithy, which will produce a plot of petal length, but then will return the original data set iris. I can run transmute Pithy and produce a sepal length squared, which of course wouldn't be possible if the select actually took hold, right? Because if I selected petal length is the only column in my data set. And so I wouldn't be able to transmute sepal length into sepal length squared because it's not there. But select Pithy returns the data set pre-select in order to let me do a plot without actually messing with my data along the way. And you can see that in addition to the plots, at the end of this chain, since I'm using transmute Pithy, that's returning the original data set. And so you can see that our iris data set, which you're probably familiar with, still has all 150 rows and the 5 original columns. So running select Pithy and transmute Pithy did not change my data set at all. So here is a little digression on effort versus quality. And I tend to think about plotting as either artisanal or industrial. And artisanal plots are created by a skilled plot maker for a specific purpose. And the quality is highly valued. And there's nothing wrong with artisanal plots. I'm not here to bash artisanal plots. They have their uses. On the other hand, industrial plots aren't quite as good, but I can produce a lot of them with very little effort, okay? And there's a place for that too. And I happen to do a lot of this at my job. So I do a lot of industrial plotting and a little bit of artisanal plotting. But the thing is that if you have an industrial plotting application, you don't want to do artisanal plots for that. It's too much work, okay? So Pither is built to produce useful plots with minimal effort, so I consider it industrial. If you want to produce beautiful plots, then it's like a small number of beautiful plots, go use ggplot2 or become really familiar with base graphics, which is the route that I've taken. But if you're doing something artisanal, do something artisanal. This is not about producing this is not about producing some plot that you're going to put in some paper. This is about, oh man, my function isn't working the way I expect it to. I want to throw a plot in there. And I don't want to spend all day writing my plot function, writing my plot code to generate a plot. So it's demo time. So anyway, let's get the demo up and running. So here is the demo, a live demo. Okay, and I'll load Magrider and dplyr and Pither. And I'll read in some data. This is the training Titanic data set, which you may be familiar with from previous meetings or the D3 meeting or things like that. And I've kind of cheated a little bit, and I noticed that there were some 0-character strings in this data set. So I set it up so that a 0-character string gets mapped to missing or NA when I read my data, because I want to notice that. I want to know that there are these 0-character strings, because usually that means something is missing. But of course, I don't know. I actually haven't paid any attention to this data set at all, because I'm just interested in seeing what's going to happen. And so if I run the summary function, right, and you can kind of see this is what happens if we run summary on a data frame, and I get, for passenger ID, That's lovely. It appears to be some sort of numeric variable from 1 to 891. Lovely. Survived, looks like it's between 0 and 1. When you have a character variable, I just find out, hey, it's a character. That's lovely. I do happen to know that there's some NAs for age. But for the most part, this is not super helpful. So what happens if I run pith on it? Here we go. Oh, and also you can use dev ask next page function if you want R to pause between every plot and wait for you to hit return before it goes to the next one. But in RStudio, all the plots just show up in the plot window. So I can just go through them in reverse order. And so this is the last plot that was made. It's the embarked variable, and I can see that there are a small number that were missing. They're actually they're the 0 character strings. But I can go back here in the cabin. That looks like it's going to need to be processed somehow before it's going to be useful. There's the fare. Looks a little skewed. Here's the ticket. I have absolutely no idea what these things are even. I don't know what that even means. But in any case, looks like there are a lot of different values there. Whatever this variable is. Or this one. Age, you can see that there are some missing data for age, and it pops right there. It's hard to miss. And male and female. Name. It looks like I got a bunch of unique values for name. That's going to have to be processed somehow if it's going to be useful. Here's P class. And here's survived versus not survived. And passenger ID, again, doesn't look super useful. Now, this is obviously not the end of your data exploration, but I got to see a lot of features of the stuff in my data for a very limited amount of effort on my part. So here's an example. So remember, fare looks kind of skewed. Maybe we should take a look at log fare. So we'll take our data set, and I'll just clear these out. Take our Titanic data set, use dplyr and transmute to produce log fare, and let's just run pith. Oh, wait. I thought that was going to work, but it looks like I've got some infinite values in my log pith. So thinking back, I was like, there's probably some 0 fares in there. So maybe I'll do something else. Now I'll take the log of the fare plus 1, and I will now use select pithy to just do the plot for log fare plus 1, and I'll save it back to my original data set. And I don't know if this is better, but at least there are no infinite values in it. And then here is an actually kind of atrocious example of using this in a sort of debugging framework where I'll create some test data, which is just some random Poisson data, and I'll create what is a toy example of a function that essentially what's going to do is look at the ratio of the larger to the smaller and return the mean of those ratios. Okay? I don't know why this would be particularly useful, but it is what it is. And here's if-else. We talked about if-else a few minutes ago. Here we have if-else. The first argument in if-else is a logical vector. So in this case, x is greater than or equal to y. So if x is greater than or equal to y, then give me x divided by y. Otherwise, give me y divided by x. So that's how that's how if-else works. So I'm only bringing that up because, it was brought up earlier. So I can't imagine how this could possibly go wrong. And it did. So when I run it on my test data, I get not a number. And although you probably have figured out what's going on there because NaN only shows up in some very special situations, I decided to just run this and just say, take my original code and instead just produce a plot. So I basically sent the value of RR to Pithy and to see what happens there. And Now I'll run my thing again, and I can see, oh, well, I do get sort of a histogram, but that's the end of what I've got for you guys. So, but if there are any questions, I'm here. Oh, I could actually show you that like pith is a function, and it just says use method pith. And if I say methods pith, you can see all of the lovely methods there. At least all the lovely methods that exist as of today. So any questions? So this does tie back to S3, really, honest, it does. Sure.
Are you able to save a plot? Is that a built-in functionality for
To save the plot?
PNG or something?
Well, you could if you want to. I mean, all you have to do is to start up a PNG device, run pith, and then close the device, and you're done. I mean, just like any other plot. You know, you could. I would assume it to be used mostly in an interactive way, but that's totally within your power. Yeah?
So what limitations have you found so far in terms of size of the data set, the depth, the width, or different types of values? I don't know, at what stage is this right now, and like what constraints have you found on different data sets?
I haven't figured out what to do with time series yet. I've been just thinking about that, but it certainly covers many of the common data classes, so it covers a fair amount right now. In terms of limitations, it's fundamentally limited. By design, it's limited, right? It's just to produce some quick plot without you spending much effort on it. So, I can probably break it a little bit if I try to feed bar plot specific arguments to it, or at least get some sort of warning about if it knows to do a histogram, but I tell it like horizontal equals true or something like that, or space, or try to give it a bar plot argument when it's going to draw a histogram, it'll probably squawk at you, unless, or I don't know, maybe. Maybe that'll happen. I haven't tried. It's not. It is what it is. It's fundamentally limited. It's built to do like one thing. Hopefully, it does that one thing really well. Yeah.
Is there any difference between like using just a dplyr select pipe and using your pipe?
Oh.
It's just so you don't have to call dplyr too?
Oh, well, the way this is working is if I've set up the package properly, if you try to install Pythor, it will try to install dplyr too if you haven't already done it, because it needs dplyr to function inside select Pythy and filter Pythy and mutate Pythy and things like that. But you don't have to have dplyr loaded as a library in order for that to work. The advantage to doing that is that, so if you consider like filter Pythy, right? So if I am using dplyr and then I run filter and then I run pith or Pythy, then what is going to be, if I go filter and then Pythy, I'm going to return the filtered data set. So if I'm giving an iris and say, I only want to look at species equals to Setosa, I'm going to filter on that, and then I'm going to do the Pythy, I'm going to get back the 50 rows of iris where the species is equal to Setosa. But if I do filter Pythy and say species equals Setosa, then it's like the filtering never happened. The filtering only happens for the purposes of the plot.
So the dplyr pipe is additive, and yours is sort of non-destructive.
It's kind of like Pythy is sort of doing like a U-turn, like go and do this thing and then go back to where you were before. Okay. Just go back. It's like a cul-de-sac. It's you want to just go and do something and then go back to where you were, so that I can, if I'm trying to debug some code, for instance, I can insert a Pythy state, called a Pythy in the middle of my chain of data manipulation, and it doesn't alter my data manipulation chain at all, right? You could do the same thing if you did So let's see if all I can show you. If you're using Magrider, right? Actually, you can do it. I can do like iris, and then if I do this filter dot, you know, that's not right. There's a in Magrider there's a pipe that's a T and then the greater than symbol, and that's a special one where it will return the left-hand side rather than the right-hand side. So and then I could do pith. So that you could do that instead of doing filter pithy, but there's a lot less typing for filter pithy. So I mean, if you want to, yeah, yeah.
Magrider also has an operator for put the results of whatever you did back in the original parameter.
Right. Yeah, that's a nice one as
I
well.
just noticed that you did that at the end of one of your chains.
Yeah,
You avoid that.
I wasn't planning on getting into the various awesome things about Magrider, as you know, but yeah, you can totally do that. I love that function actually.
Use it all the time.
Okay.
I'm downloading better tonight.
Okay. Well, you know, let me know if you find stuff that doesn't work.
Are you taking pull requests?
I will take pull requests for sure. Yeah, and for sure, am I still installed? Let's do. Oh wait, McAster, guest. Okay, for sure. I don't know. Does it let me? You see, I'm the only one who uses those letters. So you should be able to find it. Anyway, thanks a lot.